So as promised before, we're going to look at the graphs of modulus functions. So we're going to look at graphs of things like this. Y equals the mod of x. Now, we need to think about that basic definition that we had at the start. So we're talking about the modulus function. So we can say, right, well, we've got possibly two graphs here. This is either going to be the graph y is equal to x, if x is bigger than or equal to 0, or it's going to be a slightly different graph. It's going to be y is equal to minus x, and that's when x is less than 0. So I've got two graphs that are being tied up here, and there's a set domain with each of them. So let's look at the implications of this. The first part, the black graph, that's going to be y is equal to x when x is greater than or equal to 0. So in other words, on this side of the y-axis, when x is positive. When x is positive, I'm going to have the line that runs along these points here. Okay, we recognize that line as being the line y is equal to x, and it's going to go like that. But then we also have to deal with the situation when x is less than 0. In other words, when we're on this left-hand side of the y-axis. The y-axis being over here. And that's going to be the graph y is equal to minus x. So in other words, that's a graph that's going to be going along these points over here. And so I get a slightly different looking graph to what you've been used to before. And so I'm going to get a graph that runs like this. Oopsie, just missed that a little bit. There we go. And there is my modulus graph. It's mostly unlike graphs that we've seen before. We're used to the straight line graphs continuing on. We're used to seeing this graph carrying on going down here like this. But I don't draw this part of the graph because I'm only dealing with the situation when x is greater than 0. Likewise, I don't draw this part of the graph over here because it's not defined for the situation when x is greater than 0. It's only defined when x is less than 0. So we're going to draw y is equal to minus x when x is less than 0. So that is what our basic modulus graph looks like. So let's think about how this is going to be, how this will change different situations. So the next situation might be something like this. Oopsie, I don't want that. What happens when I deal with y is equal to the modulus of x plus 2? Now I want you to think back to work that you did on transformations of parabolas last year, and maybe you've got an idea about what this is already. Have a little think about that. While you're doing that, I'll just set up a set of axes. And so let's think about what our function is going to look like. If we go back to our definition says this is going to be the graph y is equal to x plus 2 if x plus 2 is greater than 0. Okay. In other words, when x is greater than minus 2. Minus 2 is over here on the graph. And so we're looking at the points. We're going to have the graph y is equal to x plus 2, and that's the line that goes like this. Got a gradient of 1, crosses the y-axis over here at the point 0, 2. Meets the x-axis at the point minus 2, 0. And so when x plus 2 is greater than 0, I'm going to have this graph being drawn here. But then I've also got to consider the situation when x is less than when x plus 2 is less than 0. I should have put an equal sign in over there, sorry. What's that going to look like? Well, that's going to be the function y is equal to minus x plus 2. In other words, it's going to be the graph y is equal to minus x minus 2. And I'm going to draw that when x is less than minus 2. So in other words, when x is at minus 3 or when x is at minus 4 and so on, I'm going to draw this function over here. That function's got a negative gradient and it cuts the y-axis over here at minus 2. But I can't draw the function. It doesn't exist over here when x is 0. It doesn't exist when x is minus 1. And it exists just before around x is equal to minus 2. So I'm now going to have a graph that goes like this. And we can fill that line in. And there it goes there. Let's get that properly on point. Obviously the graph would have continued on down over here, but our domain precluded it. This line would have continued down over there, but our domain precluded it. The domain was set over here. So we've either got the function y is equal to x plus 2, and that's when x is greater than or equal to minus 2, or we've got the graph y is equal to minus x minus 2 when x is less than 2. So this is the graph of y is equal to the mod of x plus 2. And if we think back to work we did with transformations of parabolas, this should tie in. If you remember, when you looked at the parabola x plus 2 all squared, well, we'd shifted it 2 that way, and there was our parabola going to be going over here at minus 2. So the shifts are still going to work just as they did with the parabolas. So there is our second type of modulus graph. The third type that we're going to look at today would be, what about something like this? Y is equal to the mod of x plus 2. Think about it. Think about your transformations. Have a guess at what the thing is going to look like and see if you agree with where my graph takes me or where my explanation takes you. If we look at, I'll go back to our definition. This is going to be the graph y is equal to x plus 2 when x is greater than or equal to 0, because that's the modulus value, the thing that's inside the modulus bracket. So in other words, it's simply going to be that line. Or it's going to be the line y is equal to minus x plus 2, and that's when x is less than 0. So let's see that plotted. So here's a set of axes. And let's do it red this time. So x plus 2 when x is greater than 0. So I'm going to have a point over there, I'm going to have a point over here, I'm going to have a point over there, and so it's going to continue out that way. I can recognize that as the graph that goes up there like that. And then when x is less than 0, in other words, when I'm on the left-hand side of the y-axis, I'm going to have the graph y is equal to minus x plus 2. So it'll be over here, it'll be that value there, that value there. And so I can draw my next line in. And that's the line that's going to go like that. And there we have the graph of the modulus of x with 2 added onto it. Just as we did with the parabolas, if I added something onto the end, added a number on the end, I shifted the graph up. If I took away something, I'd shift the graph down. And so the basic transformations that held for parabolas are going to hold for modulus graphs as well. That's enough for now. We've got more work on modulus graphs that we're going to deal with in another video. Goodbye.